Great. So without taking up any more of your time, delighted to thank Alison again for a wonderful paper, and to introduce Tess Colwell, who's arts librarian for research services at the Arts Library at Yale, Catherine DeRose, program manager of the DH Lab and a lecturer in statistics and data science at Yale, and Lindsay King, associate director for access and research services at the Arts Library. Over to you.
Great, I'm just sharing my screen, so hopefully you can all see that. Hi everyone, I'm Lindsay King. I'm zooming in from New Haven, Connecticut, where we acknowledge that Yale University is located on the traditional territory of the Quinnipiac, Paugussett, and Wappinger people. So last year, Tess Colwell, with whom I'm happy to be presenting today, had the idea of submitting a rapid prototyping grant with the Digital Humanities Lab here in the Yale Library to develop an application visualizing our 370,000 images and metadata from the Visual Resources collection. The DH Lab's rapid prototyping grants support focused interventions to help Yale digital humanities projects get started or develop a new feature. Our presentation this afternoon will include background on this project, a demonstration of the PixPlot prototype from Catherine DeRose, who is our fantastic colleague from the DH Lab, and a discussion on planned next steps and what we can learn from the project. So the history of this collection mirrors the development of many visual resources collections in the 20th century, going from analog to digital and from small operations within art history departments to image-related questions across campus and outside the university. Slides and photographs were originally housed in a building that's now part of the Yale University Art Gallery, pictured here, and in 2008, staff and collections moved into the newly renovated Haas Arts Library, the former Art and Architecture Library. Yale's Visual Resources collection includes more than 370,000 slides, both lantern and 35mm, and over 180,000 mounted photographs and postcards. The analog materials are now part of Arts Library Special Collections and can be requested and viewed in the reading room. The collections and their associated metadata are the result of work by countless staff over the years, as well as purchases and donations that have increased those numbers, including a recent large gift of Born Digital images and analog slides from a longtime Yale faculty member. The slides were digitized in 2007 and made available to the Yale community online. As at many other libraries, the digital images have been migrated to various systems over the years so that staff can maintain the metadata and the faculty can access images for teaching. You can see the traces of the shift from analog to digital in the images as we see them today, which might be several generations removed from the original object. An original photograph of the art reproduced in a book, photographed for a slide, then digitized. Meanwhile, more high-quality digital images become available all the time, and in many cases, the individual VRC image is not the best or the most useful. So the value of that collective collection of teaching images that the VRC represented seems to be declining for individual faculty. However, we still think there's a lot to learn from this enormous collection of images and their metadata, especially when we view it on a larger scale and from a different perspective. So with that, I'm going to hand off to Tess.
Hi, everybody. So next slide, please. So why a rapid prototyping grant? As the need and demand for a VRC slide library has evolved over the last decade, the Arts Library Digital Services staff at Yale continue to seek new ways to make the materials more meaningful to students and faculty at Yale. Next slide, please. This class is an example of how students are using the collection today. Students in the History of Art course, Photography and Sculpture in Modernity, taught by Professor Joanna Fiducia and Nick Robbins, visited us at the Arts Library Special Collections to view a selection of 35mm slides in the VRC, looking at examples of group sculptural busts and viewing the same piece photographed in different backgrounds, lights, and angles. This led to a discussion on how photography influences the way we experience art. Students looked at images side by side, the same object but different angles. And students were also exposed to physical media and a slide carousel, and many students experienced a slide carousel for the very first time. And what we discovered is that the collection is not very accessible, as Lindsay mentioned, or usable as it is. So we started thinking, how can the collection be useful in a new way? Next slide, please. So the Arts Library Digital Services staff saw an opportunity to collaborate with the Yale Digital Humanities Lab through their Rapid Prototyping Grant program that helps innovative digital humanities projects get started or add a new feature to existing projects. During the grant period, the project team built a prototype of the platform Pixplot, which my colleague will share in just a minute, using a sample of images and metadata from the VRC materials. This project aims to view the VRC images in Pixplot, where students can engage and interpret the images and metadata in new ways and at new scales, while also providing a broader perspective of pedagogical practices in Yale's History of Art department over the last 60 years. Here's an image of the ideation form that Lindsay and I sketched when we were envisioning how the collection could be utilized in Pixplot. So now I'm going to hand it off to my colleague, Catherine DeRose.
Thank you. And Lindsay, if you'll stop your screen share for a moment, I'll switch things over. For a little bit more about Pixplot before we see a live demo of it, what made the VRC a good candidate for Pixplot is the visual diversity of it. So there are a lot of different types of images contained in it, as well as the size of it. However, the size also presented a significant challenge because we say Pixplot works best at the scale of 3,000 to 30,000 images. So trying to incorporate 400,000 images represented a big increase in that. But we did try that as a first pass just to see what it looks like. And so each dot that you're seeing in this image here represents one of the images from the VRC. However, as you might be able to glean from this screenshot, it's very dense, which makes it a little bit hard to search through. And it's also a lot of images in your browser at one time, so it significantly slowed the application. So what we did for our second pass, and the one that I'll live demo in a second, is we took a random sample of 20,000 images from the VRC collection. So we're going to have a very similar overall distribution in terms of the kinds of clusters that we'll see, but since it's a much smaller scale, it'll move much more quickly and be a little bit easier to see at a glance some of the patterns that are contained in the collection. For a quick note on the underlying mechanics, Pixplot is using a convolutional neural network, which is a kind of deep learning algorithm that's used a lot for image processing tasks, such as image classification. Is there a cat or a horse in this photo? What we're doing is inspired by Benoit Seguin's work. We're taking an earlier layer of the network when the computer is still seeing in 2000 and some dimensions, and we're asking it to group images based on what it perceives as visual similarity in those 2000 and some dimensions. We then use the dimensionality reduction algorithm to reduce it back down to 2 dimensions so that a human can better make sense of what's happening with it. So for seeing this in practice, I will turn over to our live demo of Pixplot. So what you're seeing here is the random sample of 20,000 images. And on the left, you're seeing hotspots. These are the top 10 clusters that exist in the collection. And by top here, we just mean by size. And what you can do is you can zoom in on any one of the clusters. So we have figurative paintings here, modernist architecture over here. And now again, to the computer, it's just recognizing these as being visually similar. So it has grouped them without any input from us. So it's not using any of our metadata. These are labels that Lindsay and Tess came up with for the collection. What I like about some of these, the plans and sections cluster is my favorite, is that you can click on any one. You can return to the source page. So in this case, we'll return to the catalog page if I click on that eye symbol. But what I love about this cluster is that you can see a little bit about how the algorithm is perceiving this collection, because we also see Pete Mondrian paintings alongside these floor plans and layouts. And you can see, so what this cluster is probably picking up on are these really strong lines that are subdividing a region. For another feature that you can do in Pixplot is, let's say you were looking around and you saw a cluster that maybe isn't a particularly large one, so it didn't become a hotspot on its own, but it's meaningful to you in your research. You can draw a lasso around it view the different images, take ones out if there are ones you think you don't want in your collection. You can download the metadata, so you could update your catalog records if you want, but you can also create a hotspot from these images. So if I wanted to, I could just create a new one right here and say this looks like my circle cluster. And suddenly I have a new hotspot that I could save. But for some of the interesting finds we've seen so far, looking at this visual resource collection, I'm going to turn things back to Lindsay for some of the patterns.
Sure. So of course, you've just been looking at this for a few minutes, but you can see that it's really easy to jump in and try to see some of the similarities and wonder why things have been grouped together. So we can see these clusters of images, again, are grouping together as being strongly visually similar just based on the pixels and not the metadata. So Pixplot generated these clusters and then I named them. So the labels that you see are applied later. So this arches cluster, that's what we're calling it, that Kathy's showing on the screen right now, is the clearest. So you can see the vaults and the naves of cathedrals that are grouping together, even though the images are taken from different angles. Some of the other things that we see throughout the collection are objects and how they're depicted in art, like photographs and paintings of mountain landscapes are clustering together, so despite the difference in media. And then aside from looking at those named clusters that really strongly group together, when we look at how the images organize themselves, it's really interesting to see which groupings are the outliers from the larger group. So if we zoom out to the whole sample, at the very top of the sort of cloud that the images form, there's a grouping of totem poles. And then as you get closer to the rest of the cloud, you see kind of other tall figures that are not like elongated figures that are not totem poles. So just kind of interesting to see how things map in relation to each other. If you go to the very lower left, there is a grouping of these Chinese and Japanese books. And then, so those are very strongly similar to each other. And then as you get towards the cloud again, there are other types of book and text pages. So those things are distinct from each other, but similar enough that they're kind of mapping into the same area. So then if you go to the middle, there's a cluster of furniture, especially sort of chairs and cabinets that kind of group strongly together. So we just find these little islands here and there that are pretty fascinating. So we could just keep going for a long time. But so Kathy, if you will hand back to me, I will share some other screenshots that I've taken just to have it be a little bit faster to show you. So there are sort of these visual types of similarity that show up unrelated to geographic or chronological commonalities that the images have. So we may find like similar poses in figures or similar motifs. So here we have in this screenshot, you can see portraits that are clustering by people who are wearing hats in the top left. There are some ties on the right. Chuck Close portraits happen to be all clustering together. So we have domes and vaults of cathedrals clustering together. We have drawings and models and photographs of domes and towers clustering together. We might also, as I mentioned earlier, see mountains, whether they're photographed, painted, or drawn, showing up together. And then we are seeing some figures with halos from multiple traditions and painting styles showing up together. So I'm going to hand back off to Tess just to wind up our discussion.
Okay, so next slide, please. Yeah, so thinking about next steps for our project, Lindsay and I are looking into ways that we can expand the project, including collaborating with other institutions with VR collections, and kind of thinking about the overall question of like what other questions or research topics can we explore when examining VRCs beyond just and within Yale. So now I'm going to pass it on to Kathy to talk about how you can take advantage of the Pixplot platform.
Yeah, so Pixplot is completely open source. We have all of the code up on GitHub. We can drop a link into the chat for anyone who's interested. We also have sort of a README page that'll give you some of the steps on how to get started. You don't need to know much about computer programming yourself in order to use Pixplot. We're also putting together new documentation all of the time for it. And for Pixplot itself, we're working on different models that we're incorporating into it. So maybe if you want to sort images by poses that the computer detects, we're adding PoseNet as one of the things you can experiment with, as well as we're trying out different ways of giving user some controls that they can toggle on or off that will affect the overall clusters. So giving them some insight into the parameters and how those are affecting the clusters that we see on the back end. So those are some of the developments that are underway. And I think back to Lindsay and Tess for some wrap up.
So we would be really interested in just hearing from other people, but go ahead, Tess.
Oh yeah, I was just gonna exactly what you said, Lindsay. Here are just a few questions that we're exploring using Pixplot. And as Lindsay said, we'd love to hear from you. If you have any additional thoughts or questions you can think that should be explored here. So a few questions that we've been kind of talking about is like, what can we learn from the images that are collected in Yale's VRC over the years? And what kinds of explorations might be possible with Pixplot within Yale, but also outside of Yale? So with that, that's the end of our presentation. So we're really looking forward to hearing any questions you have or any feedback you have on this project. So thank you.